Hello there. Welcome to brilliantmaths.com, where every student has an opportunity to excel in math. Have you subscribed yet? Subscribe to brilliantmaths.com. Get access to all the resources that are available. Look at this. This is Brilliant Maths Module 5, Algebra 2. Today's lesson is taken from it. If you don't have a copy yet, grab one and let's work together. Today we are looking at direct variation. What is variation? Variation is very similar to proportionality. There is a direct variation between two variables when one variable is a simple multiple of the other. There are several types of variations. There's direct variation, there is joint variation, there's inverse variation, there's partial variation. We'll be looking at all of them one by one. This implies that the ratio is a constant, and if you plot the graph of that relationship, it will be a straight line passing through the origin. So for example, if x varies directly as y, it is written as x varies directly as y. But you have to change this sign of variation into a constant, and it becomes x is equal to ky. The k is called the constant of proportionality. Let us look at an example. Let's look at this example. Given that w varies directly as the square root of h, when h equals 4, w equals 6. Find the value of h when w is equal to 15. And then find the value of w when h is 9. Let's try to work this out. Solution. So read the question again. Make sure you understand. W varies directly. So we have w varies directly as the square root of h. Square root of h. So we remove this sign and introduce a constant of proportionality. So we have, so this becomes w is equal to k root h. And then we've been given values for h and w. So we input that into it. We have w is 6 and h is 4. So that gives us 6 is equal to k root 4. If we have 6 is equal to k root 4, how do we find root 4? Root 4 is simply the square root of 4, which is equal to 2. So 6 is equal to 2k. So if 2k is 6, what is the value of k? Therefore, k is equal to 6 over 2, which is 3. So now that we have the value of k, we can put that into the original equation. So that tells us that w is equal to 3 root h. So that's the formula we're going to use to find the value of h when w is 15. So w is 15 for A. 15 is equal to 3 root h. We want to make h the subject. We want to find the value of h. So we divide both sides by 3. So we have 5. Because 15 divided by 3 is 5. 5 is equal to root h. You need to square both sides to take out the square root sign from h. So square both sides. For square both sides, you have 5 squared is equal to root h squared. Therefore, h is equal to 25. So when w is 15, h is equal to 25. The next question is to find the value of w when h is 9. So for B, we're using the same equation. We're finding the value of W this time. So W is equal to 3 root H, and H is 9. So 3 root 9. This is very easy. And we know that 3 root 9 will be 3 times 3, because root 9 is 3. So W is equal to 3 times 3, which is equal to 9. So when H is 9, W is also 9. Let's look at this example. The value V of a diamond is directly proportional to the square of its mass, M. If a diamond with a mass of 10 grams is worth $200, find A, the value of a diamond with a mass of 30 grams, and B, the mass of a diamond worth $5,000. The trick to doing variation is read the question and make sure you understand. What are the key words here? Value V, directly proportional to the square of its mass, M. Those are key words. So let's take the solution. We have that the value of the diamond is directly proportional to the square of its mass. So V, which is the value of the diamond, is proportional to the square of the mass, proportional to M squared. That is, we need to remove this sign of proportionality and put a constant. So V is equal to Km squared. So if we have that V is equal to Km squared, we have been given that a mass of 10 grams, diamond with a mass of 10 grams is worth $200. So we need to input that into the equation. So the worth is the V, 200 is equal to Km squared. Constant of proportionality, we're going to find that, we don't know what it is. And then the M is 10. So we have K to 10 squared. 10 squared is 100. So 200 is equal to 100K. Therefore, K is equal to 200 over 100. And that gives us 2. So we found K to be 2. So the formula, the actual formula is V is equal to 2m squared. 2m squared. All right. So for A, the value of a diamond with mass of 30 grams is what we need to find. So we're finding V for A. So A, we want to find V when we know that the mass is 30 grams. So we input that into the formula. V is equal to 2 times 30 squared. And 30 squared is equal to 900. That is 30 times 30. So V is equal to 2 times 900. And 900 times 2 is 1,800. So we can put the dollar sign there. So that means that the value of a diamond with a mass of 30 grams is worth $1,800. Then for B, we need to find the mass of a diamond that is worth $5,000. So V is 5,000. So 5,000 is equal to 2m squared. 2m squared. So the first step is divide through by 2. half of 5,000 is 2,500, and that will be equal to m squared. To find the value of m, we need to find the square root of both sides. We need to find the square root of both sides. So m, or rather, square root of m squared is equal to square root of 2,500. And the square root of 2,500 is 50, because 50 times 50 would give you 2,500. So m is equal to 50 grams. That means that the diamond that is worth $5,000 weighs 50 grams. Interesting. Feel free to stop the video at any time and listen to it again so you will actually understand. In this example, we want to look at inverse variation. When do you have an inverse variation? You have an inverse variation when one variable is directly proportional to the reciprocal of the other, or the inverse of the other. For example, if you say y varies inversely as x, then you have that y is equal to k over x. Let's look at this example. So the keywords here are varies inversely as t squared. So let's write out the formula. Z varies inversely as t squared, so it will be 1 over t squared. So to remove this sign of variation, we say z is equal to k over t squared. And we have been given two values, one value for z and a value for t, so we can find the value of k. So z is 4. Say 4 is equal to k over 1 squared. And 1 squared is equal to 1. So k is actually equal to 4. So the actual formula is z is equal to, let's write that, therefore k is equal to 4. So z is equal to 4 over t squared. That's the formula. So now we are to calculate z when t is 2. So we come and input that into the formula. We're finding z when t is equal to 2. So z is equal to 4 over 2 squared, which is 4 over 4, which is equal to 1. So that means that when t is equal to 2, z is equal to 1. That's our A. And then for B, but to find the value of t when z is 16, so that 16 is equal to 4 over t squared. 4 over t squared. Take note of this. We cross multiply. So 16t squared is equal to 4. That means that t squared is equal to 4 over 16, which is equal to 1 over 4. Then to take away the squared by the t, we find the square root of both sides. So if you find the square root of t squared, you'll get t is equal to plus or minus the square root of 1 over 4. And the square root of 1 over 4 is half. So t is equal to plus or minus half. And that's the answer. We've been able to find the value of z when t is 2, and that value is 1. And we've also found the value of t when Z is 16 and T is plus or minus half. In this example, we want to look at joint variation. Joint variation involves relations in which one variable depends on two or more other variables. So one variable depends on two or more other variables. So for example, if Z varies directly as X and Y, then we are saying that Z varies directly as X and Y. So that implies that Z is equal to, we remove the sign and put the constant of variation or constant of proportionality, K, X, Y. In the second one, if R varies directly as P and inversely as Q, then we have R varies directly as P and inversely as Q. So that's what you have. And then this becomes R is equal to Kp over Q. The third one, if V varies as the square of U and inversely as the cube root of W, then we have V varies as the square of U, varies as U squared, and inversely as the cube root of W, so over cube root of W. So this becomes V is equal to Ku squared over cube root of W. So for joint variation, you have one variable that depends on two or more other variables. Let's look at this example that involves joint variation. Please take your time to read the question and understand, and feel free to watch the video over and over so you'll really get it. The heat H produced by an electric current varies directly as the square of the applied voltage V, and inversely as the resistance R of the wire. A voltage of 540 volts applied to a wire of resistance 40 ohms produced 1,458 joules of heat. It says, find A, an expression for H in terms of V and R. Secondly, find the resistance that would produce 588 joules of heat when the voltage is 420 V. From the reading, it sounds complex, but it is not. It's actually very easy. All you need to do is read it again and take your time to pick out the keywords. The heat, H, produced by an electric current varies directly as the square of the applied voltage V. So let's try to write out the formula. So, solution. The heat H, so we have H, varies directly as the square of the applied voltage V. It varies directly as V squared, and inversely as the resistance R of the wire. Inversely as the resistance, as R. A voltage of 540 volts applied to a wire of resistance 40 ohms produced 1,458 joules of heat. So we have that as our variation formula. H varies directly as V squared and inversely as R. So this becomes, we want to remove that sign and put a constant. So that becomes H is equal to KV squared over R. So that's the formula. We have a value for H. We have a value for V, and we have a value for R, so we can find K. So let's put in those values. A voltage of 540 volts, so that's V, applied to a wire of resistance 40 ohms, that's the resistance, produced 1,458 joules of heat, and that is H. So let's put that into the formula. We have 1,458, which is our H, is equal to K. What's the voltage? 540 V, and it's going to be 540 squared, because it's V squared, all over the resistance is 40. So how do we find our K? If you cross multiply there and you divide by that, so you have that K is equal to 1,458 times 40 over 540 squared. If you key that into your calculator to find the value of K, take your time, key it in, you'll get K to be 1 over 5. So if K is 1 over 5, we'll substitute the value of K into the formula to be able to answer the first question, an expression for H in terms of V and R. So we have H is equal to, that's the final answer for our A, H is equal to 1 over 5. So instead of the 1, we put the V, or rather the V squared, over 5R. So that's the formula we have for H, or that is how to express H in terms of V and R. And then for the second one, the solution to A starts from there and it ends here. So we can actually put it there. Let's take it out from here. So then B, we have H is equal to V squared over 5R. Next, we're going to find the resistance that will produce 588 joules of heat. So H is 588 and V is 420, and we're supposed to find R. So H is 588 is equal to V squared 420 squared over 5R. All right? We're going to make R the subject. So we'll cross multiply. Or we'll multiply 588 by R. And then we have 588 times 5R is equal to 420 squared. So R is equal to 420 times 420 over 588 times 5. Punch that into your calculator. What do you have? Found the answer? If you have done it correctly, your answer should be 60. So R is equal to 60. That means that the resistance that would produce 588 joules of heat when the voltage is 420 will be 60. So R is equal to 60. Well done. Let's look at this example that involves partial variation. Please pay attention so you'll understand. A is partly constant and partly varies inversely as the cube root of B. When B is equal to 125, A equals 35. And when B is equal to 8,000, A is equal to 20. Find an expression for A in terms of B. That's the first task. And secondly, find the value of B when A equals 215. So look out for the keywords. A is partially constant, so that's the first constant, K1, and partly varies inversely as a cube root of B. So we have the solution. A is equal to K1 plus K2 over cube root of B. Because it's inversely, so it's K2 over cube root of B. Take note of that. That's very important. So this is our formula. We need to find the values of K1 and K2. That's why we've been given two values of A and two values of B to substitute into this and be able to solve simultaneously to get the values of K1 and K2. So let's go. When B is 125, A is 35. So we substitute that here, and we have A is 35 equals K1 plus K2 over cube root of B, and B is 125. Cube root of 125 is equal to 5, because 5 times 5 times 5 is 125. So that simplifies out there. So we have 35 is equal to K1 plus K2 over 5. Then we solve. You need to multiply the K1 by 5 and the 35 by 5 to eliminate 5 from the denominator. So we have 35 times 5 is equal to 5K1 plus K2. So that's our first equation, using the first values of A and B. So next we'll use the second values. When A is 20, A is equal to 20, B is 8,000. So we're putting it back into the original equation. 20 is equal to K1 plus K2 over cube root of B. So that becomes cube root of 8,000. And the cube root of 8,000 is 20, because the cube root of 8 is 2. 2 times 2 times 2 will give you 8. And the cube root of 1,000 is 10. 10 times 10 times 10. So cube root of 8,000 is 2 times 10, which is 20. You can actually do that mentally without a calculator. So we have 20 is equal to K1 plus K2 over 20. So again, we simplify. We want to remove the 20 as a denominator. So we multiply each term by 20. So we have 20 times 20, which will give us 400, is equal to 20 K1 plus K2. So that becomes our second equation from substituting the second values of A and B. So the first equation, 35 times 5 is 175. So equation 1 is 175 is equal to 5K1 plus K2. And equation 2 is 400 is equal to 20 K1 plus K2. At this point, we all know how to solve simultaneous equations. So you solve simultaneously. You can use elimination. First, eliminate K2. Then you can find K1. And you'll find the value of K1 as 15. Solve that out. That's what you should get. And then substitute the value of K1 into any of the equations. For example, if we put it here, K1 is 15. 15 times 5 is 75. So 175 minus 75 will help us arrive at K2 as 100. So K2 is 100. So now we have the values of K1 and K2. The first question says, find an expression for A in terms of B. So that expression becomes A is equal to, K1 is 15, 15 plus K2 is 100 over cube root of B. So that's the expression of A in terms of B. We have simplified it. We have found the values of K1 and K2. The second question now says, find the value of B when A is equal to 215. So now we're finding the value of B, and we have the value of A. If you also do that correctly, you should get the value of B to be equal to 1 over 2 to the power 3, which is equal to 1/8. So work that out, and that's the answer you would get. We all know how to do substitution. You put in 215, you subtract 15 from 215, and you get 200. So cube root of B times 200 is equal to 100. So that's how we arrive at cube root of B is equal to 100 over 200, which is half. So to take away the cube root, you cube both sides. So by the time you cube the cube root of B, it becomes B. And then you cube 1 over 2, and it becomes 1 over 8. Take your time to solve it. This question can be found in Brilliant Maths Module 5. Subscribe to brilliantmaths.com, and you will see that you will excel in math. There are so many resources out there for you. And always remember, the maths is fun, and you can do it. My name is Ngozi Orevogene. See you again soon.